and welcome to the news. I'm your host, Anna Tremaine.
And I'm Axel Marwood.
Tonight, a local boy has gone missing in Pollock Park.
What we're doing today? Did you hear one? Did you hear one in there? Alfie, come back! I'm only joking! Alfie!
There's a new entry this week for Christmas number 1.
A rare species of butterfly has become extinct.
Butterfly Bentley. Bentley!
And Stuart White has been spotted spying on some tits in Kelvingrove Park.
But first, this week's science feature explores the repercussions of gene editing in wild populations.
We have with us Dr. Thompson to explain some more of the principles of gene editing.
Thank you. So, I'm going to be talking to you about genetic modification. Genetic modification has been going on for a very long time with slow progress. Processes such as model organisms and zinc fingers have been much due of an upgrade. So, in the last decade, there has been a revolutionary new process called CRISPR.
Can you see?
Although CRISPR has much to offer, a lot of scientists and a lot of people who are informed about the subject are worried about the field's breakneck pace. They fear that going so fast with the process without actually fully understanding how it works might be quite dangerous. Researchers have traditionally relied heavily on model organisms, such as mice and fruit flies, partly because of their well-known genetic code. But now CRISPR is making it easy to edit genes in many more organisms than just these ones. CRISPR works by using the Cas9 enzyme, which has been taken out of the CRISPR immune system in bacteria, which is where CRISPR gets its name. Cas9 is a non-repeating enzyme that can be directed to cut any DNA sequence by simply expressing a guide RNA code concerning the same sequence. So beyond the farm and the lab, people are thinking about how it could be used in wild populations, which is what I'm here to talk to you about today. So in wild populations there's a process called gene drive, which CRISPR could be used in, and I'm going to ask for an assistant. Axel, would you like to come give us a hand? Cheers. So, for instance, in mosquitoes, which is where people are really hoping to make an impression, a disease-free gene could be inserted into the mosquitoes and spread throughout the population. Usually, a genetic change in one organism takes a long time to spread through a population. That is because mutations only carried to half of the offspring. So you've got your parent here, who's got the change. It's only carried to half of his offsprings. So, gene drive works in that when the mutation comes in, it automatically is put into every single offspring. So, when that one breeds, all his offspring have got the mutation as well. So therefore, it gets through the population a lot faster. Now, Axel is going to be my mosquito. Well, I brought some samples here for today. Now, this one's just a bit of a show and tell. It's one of the samples we're working on in the lab. It's very, very deadly. It's a mosquito disease. Can't exactly tell you what it is because that would be breaching confidentiality. Now, if you were to bring this out into the human population, for instance, it would cause some strange mutations. But none of that today. Now, what I have also got is a pretend sample of one of our anti-disease genes, as in you put it in the population and it spreads immunity from a disease. Now, this is a pretend sample because, Axel, I'm going to ask you to stand here, and you're going to be my mosquito. So, we're going to pretend we're giving you a blood sample. So this is the safe one, obviously. Now pretend this is the blood meal from the lab, and this has got the autoimmune gene in it. So Axel our mosquito is going to be using this, and he's going to be spreading it around through the populations. Now, he could go around and he'd be biting other people. You could have a bite of me if you want, and that would spread that gene into that human host, and then other mosquitoes would be sucking that blood up, and they'd be spreading it, and because it's a gene drive, it would be working a lot faster than a normal method. So, thank you, Axel. Oh no, see, I want to shake your hand.
And now we cut to Martha in the field.
Hi, I'm Martha, and I'm going to go speak to the public about what they think about gene editing. we're looking at manipulating genes in a wildlife perspective, focusing on wildlife disease.
Okay, fine. So I suppose you can
market
remove disease, but the issue is if you remove certain defects in the gene, then if there is a disease, it can wipe a lot more of the population out. So I guess that's the risk, isn't it?
It is, yeah. I guess.
And a certain disadvantage actually might be a benefit.
Do you know what gene editing is?
First thing of GMOs, and I think they're actually a good thing because they increase harvests.
Yeah.
And for hundreds of years we have been manipulating the genes by just selecting the better fruits.
Yeah.
So yeah, I'm totally for GMOs because I think that's a good thing and that's how we're going to be fed in the next century, or not. I don't know about editing genes of animals or cloning. I have not really thought about that.
Nobody really wants to speak to me. Do you have time to speak for a minute? For example, is malaria. So manipulating mosquitoes so that they don't spread the disease. Do you think this is ethically okay? What's your opinion on that?
If it's around mosquitoes, then maybe it's
Yeah. Okay. Thanks for your input.
no worries.
Cheers. Have a nice day.
Thanks for that, Martha. And take care.
Now we cut to Michael, who's speaking to some leading experts at the Science Place.
Hello, I'm here with Professor O'Brien to discuss why gene editing is so revolutionary. Professor, what is your opinion on gene editing? I believe great things are achievable through gene editing, especially in wild populations. What do you mean by great things? Well, so many people around the world are affected by diseases such as malaria and dengue fever. These diseases could be greatly controlled with gene editing initiatives such as gene drive. Oh really? How so? Well, imagine you insert a gene into a mosquito population. This gene decreases the number of offspring that a mosquito can have, and now if you insert that gene into a large enough proportion of that population, you're going to see a vast drop in the number of these vector species. Well, that all sounds great, Professor, but do you not see any risks with using such a new procedure in such broad applications? Well, everything in science is being new until someone starts using it. This has been closely monitored. We're not just adding things and infecting people willy-nilly. Well, plans for gene editing applications have to go through rigorous testing and planning until they are approved. But is it not true that some applications, such as the use of CRISPR, have led to some unexpected side effects? In some cases, the Cas9 gene has been known to affect a number of other genes, but these changes have been proven to be minor, while the main effect of the gene is still being carried out successfully. Any kinks that have happened along the way with gene editing, well, I'm sure they can be worked out. Perhaps with gene editing. Very interesting. Thank you for your opinions, Professor O'Brien. Thank you. By the way, have we met? You do look very familiar. Not that I know of. Back to you in the studio.
Thanks for that, Michael.
We're gonna go back to
We're going to go back to Martha in the field, who's speaking to an informed citizen.
Really?
Hello, so I'm with Megan Kirk here, who is a zoology student at the University of Glasgow. So Megan, what are your main concerns with the gene editing technology we now have?
My main concerns is anything that I've read or seen about gene editing technology has always suggested that it's a very powerful tool in the lab that we can now use, and it's getting cheaper, simpler and quicker to use, and my main concerns are who can get their hands on this kind of experimental tools.
Okay, so what about its use on wild animal populations?
So already they're looking at using them on mosquitoes, and mosquitoes are a particular area of interest because mosquitoes cause issues and illnesses in human populations. And most people are like, oh, it's a mosquito, who kind of cares? But then where do we stop? It gets bigger and bigger and we start moving to other animals, and animals can't speak for themselves, so who stands up for the animals and says, no, I don't want to be edited? This is going to cause a huge kind of ecosystem equilibrium issue, because ecosystems are very sensitive, and if we go in and start editing genes and doing what we want and what we wish with animals, do we then become the driver behind natural selection?
What would make you feel less concerned about gene editing?
So, as I've already said, my main concerns are when do we know where to stop? So there needs to be definitive rules and regulations surrounding this kind of technology. They need to have more information on who this technology is being used on and what cause they're using it for. Especially in the wild population, we need to do field scale trials to make sure that in a contained, controlled environment that these gene mutations aren't going to boom.
Thank you very much, Megan. And back to the studio.
Action.
Breaking news. Something's happened to my co-host. Stay in your homes. Michael's on the chase.
Have you seen this man? Have you seen this man?
Okay. Revolutionary new process of. Oh no.
Properly is. You are killing me, man!
I think you're white isn't spotted spying some tits. It's fine.